Okay, this lesson is equations with variables on both sides. Let's jump right into a U-try. See if you can solve this. Find the value of x in the diagram. You've got 6x plus 3 degrees here, and you've got 8x minus 21 degrees there. Go ahead and pause the video and give this a try. When you're ready to check your answer with mine, press play. Okay, let's see. If we remember our geometry, we've got vertical angles here. And we learned in geometry that vertical angles are congruent. So that means that the 6x plus 3 has to equal the 8x minus 21. And that almost seems intuitive without even knowing the geometry, that these are the same measure. So we've got variables on both sides. The way I like to solve having variables on both sides is to get them all on one side as quick as we can. So I'm going to subtract 6x from both sides. The reason I'm subtracting 6x instead of 8x is because I like it when the x's come out positive if possible. 8x minus 6x is 2x minus 21. Now we're going to go ahead and add this 21 to both sides, undo that subtraction. The result there is 24 is equal to 2x. And now we'll undo the multiplication by 2 here on the x just by dividing both sides by 2. And 12 equals x. We should be able to check that by plugging 12 in here. 6 times 12 is 72 plus 3 is 75, so this would come out to be 75 degrees. 8 times 12, what is that? Let's see, 80 plus 16 is 96. Minus 21 is also 75 degrees. So x equals 12 is the right answer. You can't be wrong. Okay, this next problem, you go ahead and give this one a try too. See how you do. Press pause and press play when you're ready to check your answer with mine. Okay, on this problem, I think I'll go ahead and distribute the 2. So I'll have to take the 2 times the 5 and also the 2 times the negative 4 and see what I get. So the left side stays the same, 10 minus 8x. 2 times 5 is 10. 2 times negative 4 is negative 8x. This is going to be interesting. I'm trying to get the x's all on one side. When I add 8x to both sides, an odd thing happens here. My x's just zero out, and I'm left with 10 equals 10. Well, it turns out that that's a true statement. 10's always equal to 10. That means it doesn't matter what x is. So the answer to this question is all real numbers. X can be anything. And this is a symbol we use, and so we don't have to write all real numbers. So there we go. We could test this by just picking 2 or 3 different values of x and making sure that it works. Here's another one for you to try. Go ahead and pause the video, give this a try, and see how you do. All right, I would attack this first by noticing that I have 7x and negative 1x on the same side. So I'm going to go ahead and just combine like terms on this right side. 7x minus 1x is 6x. I have 6x plus 7 over there. I want to try to get all the x's on one side, so I'm going to subtract 6x from both sides. And that odd thing happens again where all the x's just zero out here, and I'm left with negative 5 equals 7. That's a false statement. That's never true. That means it doesn't matter what x is. This will never work, so the answer here is no solution. Go ahead and try this one. Okay, again we have x's on the same side, so we're just going to combine like terms. Keep the negative 6x plus 8. That equals x minus 7x is also negative 6x plus 10 in this case. I think you can see where this is going. We're going to add 6x to both sides. That zeroes out the x's, and we're left with 8 equals 10, which is false. This also has no solution. It doesn't matter what x is. This will never work. This one will have a solution. Let's see. I want to get all the x's on one side. Actually, you try it first. Go ahead and press pause and give it a try. All right, I want to get all the x's on one side. So I'm going to subtract 3x from both sides. That'll give me x minus 3 equals 4. When we add the 3 to both sides, we isolate x, which is what we're trying to do all the time when we solve. X equals 7. Let's check that. 4 times 7 minus 3. Does that equal 3 times 7 plus 4? Well, this is 28 minus 3. This is 21 plus 4, and we can see those are both going to be 25. So that checks. This is right. It can't be wrong. Let's give this one a try. Go ahead, pause the video, and see how you do. Okay, on this one I've got to use the distributive property. I've got 4 times x and also the 4 times 5. So let's leave the left side alone and distribute the right. 4 times x is 4x plus 4 times 5 is 20. We want to get all the x's on one side, so I'm going to subtract 4x from both sides. And the result here is 2x equals 20. Let's undo that multiplication by 2 using division. So we're going to divide both sides by 2, and x equals 10. Let's give this a check. Let's see if we can check this on our head. 6 times 10 would be 60. 10 and 5 is 15, and 4 times 15 is also 60. 60 equals 60. That checks. This has to be right. It can't be wrong. Go ahead and try this one. See if you can get all the way through this one on your own. All right, let's see. On the left side, I have a negative 2 to distribute, and on the right side, I have a negative 1. There's an implied 1 here. It's not written, but we can stick it in there if we want to. It's negative 1 times all that stuff. So on the left, I'm making sure I distribute a negative 2 through all this stuff, and on the right, I'm going to make sure I distribute a negative 1 through all this stuff that's in the parentheses. So let's see. I have 5x. Negative 2 times x is negative 2x, and negative 2 times positive 2 is negative 4. That equals negative 1 times 2x is negative 2x, and negative 1 times 15 is negative 15. On the left, now I see that I have like terms that I need to combine up, so I'm going to go ahead and do that next. 5x minus 2x is 3x, and then I have minus 4 equals negative 2x minus 15. I've got variables on both sides. I've got an x on the left and an x on the right. I'm going to try to undo that. I want to get them all on one side, so I'm going to undo subtracting 2x by adding 2x to both sides. Keeps all my x's positive in the end, which is what I like, if I can get that. 3x plus 2x is 5x, minus 4 is equal to negative 15. Now I'm going to start undoing the x on this left side. I want to get this by itself. First thing I need to do is get rid of the 4, so I'm going to undo minus 4 by adding 4 to both sides. So I've got 5x equals negative 11, and now we're going to divide by 5 and get a fraction this time, it looks like. We're going to be checking this one for sure. X equals negative 11 fifths. First, let's just do a quick check to see if we can find a mistake. Distributed, that looks good. Distributed, that looks good. Combined, that looks good. Let's see. We added this over, that looks good. We added that over, that looks good. So let's go ahead and plug it in and see if it works. So I've got 5 times negative 11 fifths minus 2 times negative 11 fifths plus 2 equals the opposite of 2 times negative 11 fifths plus 15. You know what? I'm just going to plug this into a calculator and see what I get. Well, when I plugged that into a calculator, I got negative 10.6 on both sides. So I had a negative 10.6 here, I had a negative 10.6 there. Therefore, x really does equal negative 11 fifths. That answer checked, therefore it can't be wrong. You might want to back that up and see how that works again. I can't get that to redraw. I don't know why that disappeared on me, but it did. Okay, in this next problem, we've got a word problem to deal with. We've got one cell phone company charges $16.95 per month and 5 cents per text message. Another charges $22.95 per month and 2 cents per text message. For what number of text messages per month is the cost of the plans the same? Let's make a little more room here and also highlight some information. Let's call it the blue plan and the green plan. One is $16.95 per month and 5 cents per message. So that would be 16.95 plus 0.05, let's call it M for the number of messages. We want to know when that equals the green plan, which is 22.95, and then plus 0.02 cents per message. We just want to know how many messages would make this equal. For what number of text messages per month is the cost of the plans the same? Again, we've got variables on both sides. In order to help clean that up, I'm going to try to get them all on one side. So I'm going to subtract the 0.02 m from both sides. The result there, 16.95 plus 0.03 m is equal to 22.95. Next, I'm going to go ahead and subtract the 1695 away from both sides. The result there is my 0.03 m is by itself now. The 0.95's zero out. 22 minus 19 is 3. So m, let's see, if I want to get m by itself, I need to divide by this 0.03 and 0.03. If we take 3 and divide by 0.03, the result is going to be 100. So it's going to take 100 text messages to make those plans equal. How'd you do on that one? For learning target, I'll see you in class.